everybody? Can you all hear me okay? Cool. So hopefully you're at the right place. Introduction to Kotlin. Just quick show of hands. Who's used Kotlin in any capacity of any kind at all? Production, testing, screwing around, anything? Awesome, cool, a couple of people. So what's in a name? People ask, well, where did the name Kotlin come from? You look at this picture, this is Kronstadt Bay. To the east of Kronstadt Bay is St. Petersburg, Russia. The team that developed Kotlin is from St. Petersburg, and they wanted to name their new language after an island, so they picked one close to home, Kotlin Island, which is the sort of traditionally and historically been the gateway to Kronstadt Bay and has defended St. Petersburg from invaders by sea. So now you know why it's called Kotlin. So today we'll talk about what is Kotlin. I like to not be the only person using something. I like a little bit of herd immunity around me when I do something, so we'll talk about that. We'll spend a lot of time going over this. I'm sorry? Yes, please, if you could.
I think it's getting locked. People cannot come inside. So you struggle to close it.
Oh. Well. Thank you, my friend. We'll spend a lot of time going over syntax and features. We'll summarize it, and if you could hold your questions until the end, I've got like a full 50 minutes of stuff for you. So if you can hold questions to the end, I'll stick around. I'll be around all day and all day tomorrow if you have questions. I'm Todd Ginsberg. I've just moved from Chicago to Dallas and then possibly not staying there, I'm not really sure. But I work remotely for a company in Austin, Texas called Netspend. We have an office here in Alpharetta. We love Java, we love Kotlin, we love people who love Java and Kotlin. If that's, it's a payments company, if that's interesting to you, come and talk to me afterwards. I might draw a comparison from Kotlin to some other language like Java or Groovy or Scala or some other language that you love. If I say it in a way that makes one language look better than the other, or it's purely out of love. I've written Java for 25 years. I'm wearing Java socks right now. I love Java. So if I say something about Java, it's just a comparison. It's not to denigrate. So what is Kotlin? Kotlin is a statically typed language developed by JetBrains. They're the company that is responsible for IntelliJ, all this great tooling. They have a booth out here. And it's been released under the Apache 2 license. So you're not going to run into a situation where, say, some giant company says you can't implement their interface in a specific way. Not that that happens in our industry. But you can go and contribute to this language if you'd like to. And although we'll talk about it from a Java point of view, this is designed as a general purpose language. And what I mean by that is when you write Kotlin, you can target either Java 6 or 8 bytecode. There's newer bytecode targets coming when there's something interesting that they'll do for the language. You can target to JavaScript. You can write Kotlin and have it output JavaScript. You can have it output native code. So at KotlinConf last year, they had an Android app, an iOS app, a web app, and a backend, all of it exclusively written in Kotlin. There was no native, there's no Swift or anything like that on any of those platforms. So although it is a general purpose thing, we'll focus mostly on the Java flavoring of it today, because it is 100% interoperable with Java. So you can take, one of the great things about Java is this 25 years of history. We've got a lot of great libraries that do a lot of great things. You can pull all of those into Kotlin and use them without any modification at all. So this is all the stuff you have checked into your repos at work or at home or whatever. It all works perfectly fine. And Kotlin as a language is designed to avoid entire classes of defects. And you'll see what I mean by that. I'll try to point it out as we run into the examples. But what I want you to understand is that in this is a more modern language than we're probably used to. We've learned a lot of these are things that we shouldn't be doing as programmers. And these things are built into the language, and the compiler is doing the difficult work for us rather than having to rely on external static tools or things like that. And a lot of these things I'll show you, you might say, well, that's a tiny little improvement. That's just a little bit of the difference. And those things add up. They're everywhere, and they add up to a better developer experience. And I've found that I write far, far less code when I'm writing Kotlin than Java. My boss isn't paying me to write code. My boss is paying me to deliver business value. And if I can do that with less code that is more clear and succinct, all the better for the people around me. So one of the big features you hear about Kotlin is its null safety. Null safety If you don't think that's a problem, go look up on GitHub. There are 196,000 issues on GitHub just today of people complaining about null pointer exceptions. These are just on GitHub, just the ones people have bothered to mention. Go look in all your Jiras or whatever you use and see how many null pointer exceptions have made their way into production. On Stack Overflow, there's 15,262 duplicates to the question, what is a null pointer exception and how do I fix it? Right? These are people coming into our industry who have no idea what this is and getting confused. This largely goes away in Kotlin. And that number, actually, you can go up to Stack Overflow. They've got an API, like a SQL query API you can use to answer questions like that. It's pretty fascinating. And when I go through the syntax, you might say, hey, they stole that from Groovy, or hey, they stole that from Scala or something. They probably did, and that's okay. It's okay to take a pragmatic improvement that somebody else has done and pull it into your language. And I think Kotlin does a really good job of taking the best from learnings in the past and putting them into a language for developers to make it easier for them to work with. And one of the major features for me with any technology that I choose is a positive community. I don't have time for, read the fantastic manual. I don't have time for that. I don't like communities like that, and Kotlin is definitely not like that. Even on Stack Overflow, there's a bunch of nice people on Stack Overflow, which, not every tag has that. So I like that a lot. And like I said, I like a little herd immunity around my technology. I don't like being the only one doing something. So you might have heard that Kotlin is very good on Android. In 2017, Google said, sure, give it a try. See if it works. We'll see what we think about that. In 2018, they said, you should prefer using, if you're starting a new project, you should prefer to do it in Kotlin over Java. And this last year, they said, you know what? Everything we're going to do is in Kotlin first and Java last. We're going to have better examples. We're going to have Kotlin-focused demos and examples and libraries. Excuse me. Anybody Spring developer in here? Anybody using Spring Boot? So like almost everybody. Since Spring Framework 5, Kotlin has been a fully supported language. In Spring Framework, you can go up to start.spring.io. You can initiate a Kotlin project. They went through the entire framework and annotated parameters and fields with not null, which helps when you bring it in. When you're bringing a Java library into Kotlin, it helps make the nullability answer a little bit easier to calculate. And like any Spring project, there's very good comprehensive documentation and examples in Kotlin. And there's a Gradle DSL. If you're into Gradle, anybody using Gradle? Okay, a few people. Wow, that's more than I thought. That's cool. There's a Kotlin DSL in addition to the Groovy DSL. I haven't, I'll confess I've got it on a couple of projects, but I've got a lot of projects still in Groovy and the Groovy DSL, and they still work fine, but there is a Kotlin DSL that's a little bit easier to debug. It's maybe got a couple more features coming in the future. So check that out if you're using Gradle. So let's get into the syntax. This is where the fun starts. Kotlin has this idea of variables and values. So in this case, we've got var called place, which is type string, and we'll set it to the word Atlanta, right? So you'll see in here, the type and the name are backwards from Java, and you'll see why in a second. Now this is a variable. That variable means I can change it. So I can set the place to Georgia instead of Atlanta, and that's totally fine. Now, on the other hand, I've got this value. It's a name, it's type string. I'll set it to my name, Todd. If I want to set it to my daughter's name, Emma, it's a val. I can't change that. It's immutable. It's going to stay that way, and the compiler is going to enforce that for me. We'll move into type inference. In this case, we've got two vals. I've got D, which is an int of 2, and the string, text string says Todd has $D doughnuts. Now, two things I want to point out to you. That Todd has $D doughnuts will print out to Todd has 2 donuts. It does this interpolation for you. The compiler is going to take that string, it's going to write the correct bytecode of whatever string manipulation it needs to do, string concatenating, or whatever the most efficient way to do that, and write that in the bytecode as if you had done that yourself, right, with a string builder or whatever it decides it needs to do. And like as an aside point of view, if any of you are locals and know a good donut shop around here, come and see me after, because I love donuts. The interesting thing I want you to show you is these two types. Now, it's pretty obvious when you look at this that D is an int and text is a string, so you can just leave those off. You don't have to. Kotlin is able to infer what those types are. D is still an int. Text is still a string. We're not getting rid of the types. We're just not specifying the types. And that's really nice if you're writing code in a function or something and you don't want it to have a lot of noise, you can do that. I tend to leave them on because I like the labels for myself, but sometimes I leave them off, and a lot of people do leave them off. And it leads to a lot clearer code with a lot less noise in it. Equality in Java is one of those things I think that screws a lot of people up when you join the language. If you're doing primitives, you've got to use double equals, and if you're using objects, you've got to use dot equals. In Kotlin, anytime you want structural equality, meaning are these two objects composed of the same things, you use double equals for that. And it will write, again, it'll write the correct code for you underneath. It'll write a dot equals or an equal for you underneath. And if you want referential equality, are these two objects pointing to the same place in memory, you can use triple equals for that. It's a lot less common, so people have to type one more character to do it. But it's a lot less confusing. So again, this is a little thing, but these all add up. You'll notice in these examples, I'm not using any semicolons either. They're also not required. You don't have to, they're optional in Kotlin. I don't know any practicing Kotlin developer who actually exercises the option to put semicolons in there. But it's a little thing, it adds up. Has anybody ever done this? You put like one of these ugly strings in here with like, escaped characters for SQL or JSON or something. It's really ugly. We can do raw strings in Kotlin. If you put 3 quotes around it, you can put whatever you'd like inside. Java 14, I think, has this, or 15 is going to have it. But you can use this now in Kotlin. You can space them out. Anything you put in there, new lines, tabs, whatever, it'll get put in just like this. That's a really nice feature to have. Regular expressions, I use this for a lot because I feel like you get kind of carried away escaping things in regexes, so I use them there a lot. Null safety. Let's talk about this. This is the big feature everybody talks about with Kotlin. So in this example, we've got a name of type string. And by saying it's a type string, I'm telling Kotlin, I'm never going to allow you to make that null. It's never going to be null. On the other hand, if I put a question mark after my type, in this case, the salary, there might not be a salary. I'm putting an int with a question mark. I'm telling the compiler, this can be null. This is allowed to be null. Now, some people call this an int, and some people call this a nullable int or a maybe int. We'll call them nullable types from now on. Now, you'll talk about, people will say like, nulls are this billion-dollar mistake, right? And I don't necessarily believe that. I think a null is a perfectly reasonable way to represent the state of something. The mistake is allowing developers to chase a null reference without some help. And so Kotlin gives us some help. In this example, we've got a city, which is a type nullable string, and it's set to Atlanta. If I want to call a function on that string, I can't, because it's saying that might be null. Now, in this example, they're right next to each other. It's obviously not. But Kotlin's not going to let me if it can't determine that those are nullable, right? So what I have to do is say, ooh, it's loud in here. I have to use the safe traversal operator, meaning if I call to uppercase on city, if it's not null, it'll call to uppercase on it. If city is null, the whole expression will evaluate to null. And in this case, we're going to do another one. It's called Elvis. Elvis is another tool we can use to get away from nulls. So in this example, we've got a list of 1, 2, 3. That's another nice thing from the Kotlin standard library is just to say list of, and it'll give you a list of.
It worked out.
Okay. You get a list of, and it'll give you a list of whatever types are in there. You don't have to think about it. In this case, we're calling min. We're asking it for the minimum value. Now, there might not be a minimum value, so Kotlin's going to say, it's going to give us a nullable version of whatever type is in that library. But I don't want that. I want a regular version. I want a non-nullable version. So what I'm going to say is, I'm going to use the Elvis operator. It's called Elvis because if you turn it on its side, apparently it looks like Elvis Presley, and I'm like the only person on the planet who doesn't see this. But what happens in this example is if the left-hand side evaluates to null, it'll just start evaluating the right-hand side. So in this case, it'll default to 0. But we could make that right-hand side any kind of expression we want, any arbitrarily complicated thing. And so you'll see these together a lot. Println is another great thing from the Kotlin standard library. You don't have to say system out. You could just say println. And in this case, what we're saying is if the city is null, is not null, to uppercase it. Otherwise, the value is unknown. So you'll see safe traversal and Elvis together there. So this version, I'm always reluctant to show this version to people So here's another tool. If we've got our same thing, our same list, we're asking for the minimum value. There's a tool in Kotlin we can put 2 exclamation points after this. And this is telling Kotlin, I'm a person and I know better. I'm smarter than you because I'm a person. So just turn off all your null assertions. I know this will never be null. And in this example, it's fine. You can totally do that. But in this example, where I have an empty list and I call null and I say I'm a person and I'm smarter than you, I'm not smarter than them because I'll end up with a null pointer exception. So in some cases, some people say, yeah, Kotlin, there's no null pointer exceptions. It's not actually true. You can do it. You just kind of have to go and shoot yourself in the foot to do it. So remember the names. It's important. We'll use them later. Question dot is the safe traversal operator. This is the Elvis operator. And this is the hold my beer operator. A neat thing about Kotlin is that expression, if is an expression. So in this case, an expression is something that returns a value rather than just has side effects. So we set our status to either success or fail, depending on what value of code is. True or false is also an expression. In the catch statement here, we can run anything arbitrarily complicated. I'm just keeping it simple by making it a 0. But that's also really nice. I can set number to whatever this try-catch expression is. And when is like a switch on steroids. So in this case, we don't know what x is, the subject of when is. But we can evaluate it against a number of things. We can say, is it 0? Is it in this range? So that 1.10 is a range operator. Ranges are first-class citizens in Kotlin. Again, another little thing. It adds up. We can test if it's in some set. We can test if it is some type. We can see if it's equal to some parsed string example. Or else, instead of default, we can do some default case at the bottom. Now you'll notice that I don't have any brackets or continues or breaks in here. Switches in Kotlin break by default. I don't have to keep putting that because I think in 25 years of Java, I've wanted a switch statement to fall through maybe once. So they don't fall through by default. If you want them to fall through, you can make them fall through with a continue. But again, it's a little thing. It's something that most developers need it that way, so let's just make it that way. And now that we know about all those things, we can talk about an interesting thing that Kotlin will do for you with types. So when we have x, it's either an int, a string, or an int array in this case. And if you look on the right-hand side, we're doing something type-specific with each one of those. And x in each one of these cases is a completely different thing that's depending on the type. So what Kotlin's doing here is smart casting. It's saying if you're evaluating something on the left, you almost certainly want that type on the right. You're going to do an instance of or a cast on the right-hand side. So let's just assume that we've done that. And so Kotlin will turn the right-hand side into an int, a string, or an int array in these cases. It's called a smart cast. It does that for nullable too. If x is nullable in this case and cannot change between the time I evaluate it and the time I use it, it's smart enough to know that I've already evaluated its nullability to false, and I don't have to use the safe traversal operator there. So classes, Kotlin has classes, Java has classes. In Kotlin, we don't have to say instance of or extends. We can just say colon and then a list of whatever things we're extending or implementing. There's still only single inheritance. You can still only descend from one class, but you don't have to say anything. You can just say colon some interface. And this class is final by default, meaning it's closed. You can't extend it by default. So this is forcing the developer to make a decision whether you want something to be able to be extended or not. So if I want it to be extended, I have to say it's open. And then I can have a subclass customer, which extends entity and calls its default constructor there if I want it to be open. Properties. If you're a Java developer, you've probably written dozens, thousands, tens of thousands of things like this. We have a private field called name. We have a getter that gets. We have a setter that sets. There's nothing magical or interesting about this code, and we've all written them or had our IDE write them thousands and thousands and thousands of times, right? And it's noise. It's something you've got to look at. When you pull your code up in the editor, it's something you've got to look at. In Kotlin, we've reduced this down to a property. This is the same code. It's doing the same thing. It might look like I've got a bare field called name, but really underneath there's a getter and a setter. They're there. You don't have to see them because they're just getting and they're just setting. So for an example, let's create a customer. I've got val c equals customer. And in this case, I don't have to call new. Or I don't have the new keyword in Kotlin. It doesn't exist. And like when you go back to Java after writing Kotlin for a while, that is the hardest thing to unlearn, is not putting new keywords in there. I've spent a lot of time debugging why I'm an idiot because of that. So in this case, I can say c.name equals Todd. It looks like in Java that would be just hitting the bare field and assigning to it, but I'm not. I'm really going through the setter. And on this println, another better example of string interpolation there. I'm saying, I'm calling the getter, c.name. So if I want to change the getter in the setter, I can do that, and it should stand out. If somebody's doing something weird in a getter or a setter, it should stand out. So I can define it, and we won't go through the details of the syntax. I'm just showing you that it can be done. I can define the setter. I can make it private. I can define the getter. There's, again, if you're doing something weird with a getter or a setter, other than just getting and setting, they should stand out. I can also delegate properties. Let's suppose I've got this country object, and calculating the GDP of it is presumably quite an expensive operation. I maybe don't want to do that every time. I want to instantiate a country and not have it bother to go and do all the hard work for me right away. I'd rather have it I'd want to do it only when I ask for it. So in Java, I'd have to have a null value. I'd have to have some kind of lock. I'd have to synchronize. I'd have to calculate all this. In Kotlin, I can use the lazy delegate. So I say by lazy, and I pass it some lambda. And what happens is Kotlin doesn't do anything with the GDP in this case unless and until I ask for it. Then it will synchronize callers so that the two people aren't calculating it at the same time. And it will remember the answer so that the next time somebody comes through after it's calculated, we don't have to do any more work. And that's all for free. I just say by lazy. There's other delegates in there. You can write your own. There's one out of the box for vetoing changes, for and observing changes. And they're pretty handy. I can do this with classes too. So in Java, let's pretend we've got this huge interface. It's got maybe 50 different methods on it, and I want to do something special with it. I want to do a delegate like to a list that does something that logs something or whatever. I have two options in Java, right? I can come up with my own class called myJavaImpl and implement huge interface and take a backing version, like an actual implementation, and just delegate through to everything, right? Now I'm going to end up with a lot of code, 50 methods, that mostly just delegate to something else. Now for me, that's a pain in the neck. The other way I could do this is I could say, I could pick as the developer of this function, or this class, I could pick an implementation and just descend from it and force you to just live with that. Now you might not like the fact that I extended linked lists. You might say, well, why didn't you extend array list or whatever other kinds of list? And you'd be right. But from my point of view, I only have to implement the 3 methods that I want. So for me, it's easy, but for you, you might not get what you want. Now Kotlin, I can do best of both worlds. In this case, I've got myImpl, which takes a huge interface, h, and I'm saying it implements huge interface by h. So what that does is anytime you call a method on myImpl that would land in huge interface, it's just going to get called through to h. I don't have to delegate. I don't have to do any of that manually myself. It's just going to do it for me, unless I implement it in that class, and then I can do whatever I want. So again, things need to stand out. Like for example, I needed a list that I could address circularly, so I could get the -1th element of a list. I did it this way, and I implemented it in about 10 lines of code. And if I did that the other way, I'd have to implement the entirety of the list and a lot of delegation, and the things that I actually cared about that I needed to focus on and show you when we're doing that code would take up, a little tiny bit in pages and pages of code. In this way, it would stand out. So let's write a POJO. We've all done this again too. I've got a public first name and a public last name field, and we can't check that in because we need to make them private and have getters and setters. So I'm going to get my IDE to do that for me. I'm going to get my IDE to give me a no arguments constructor and an all arguments constructor. I'm going to have my IDE create an equals and hash code. I'm going to have my IDE create a toString for me, right? Now we've created a POJO. Well, I've written 3 lines, and my IDE has written 47 lines. This is the equivalent code in Kotlin. It's called a data class. This is a great gateway to sneaking Kotlin into your project, by the way. Just replace some DTO, some POJO, something that your REST API returns with a data class. It's a great way to sneak Kotlin in. Not that I've snuck Kotlin into a project at work officially. So you get everything you get getters and setters. The first name and last name are getters and setters or have properties, so they're getters and setters. There's a default toString. If you don't like it, you can override it, provide your own. There's default equals and hash code. I'm not smart enough to write my own hash code. I always get the IDE to do it for me, but if I did want to write it, I could do that. I could override them. I also get copy constructors. So in this case, I've got a data class with just 2 fields, But suppose I had one with a lot of fields and I wanted one that's just kind of slightly different from that. I could say, copy it and change the first name to Emma, my daughter's name, and now I've got a new instance of that. Let's move to functions, because functions are fun. Would you mind waiting? Go ahead, quick.
Sorry, do you mind if I ask now, or can we wait until the
Would you mind waiting till the end?
Yeah.
Thank you, I appreciate that. Let's talk about functions. So in this case, we've got a function called getRandomNumber, which returns an int. Again, the type is on the end. You might see where this is going. And it returns 4, because that's totally random. If I can express my whole function as a single expression, I don't need the brackets. I can just say this function equals 4. Now, in this case, I'm just saying it's 4, but again, I could do, remember if and when and try are all expressions. I can do something like that if I wanted to. And if I could do it as a single expression, I can leave off the type. Now, in this case, in practice, I don't generally leave off the types. I like them as labels, because if I change 4 to a 4.0, I've suddenly changed the type of my function, and that might not suit everybody. I leave them on for labels, but you can unless they're private, but you can totally leave them off. Functions can have arguments can have default values. So in this case, we're saying we have a random function. It's got an offset whose default value is 0. So if I don't pass anything to random, it's assuming it's 0. If I pass something to random, it's just saying the offset is 1, whatever it normally is. And this is helpful because if you've ever been in a situation where you've got, say, a method that has 3 parameters, and now you need a version with 4, so I've got to have the 3-argument version called the 4-argument version with some sensible default, I can just add a 3rd argument to this one and give it a sensible default. And the compiler will do the right thing underneath and create the correct number and type of functions that have the 2 and the 3 argument, and I don't have to care. I can call this with either 2 arguments or 3 arguments. It really doesn't matter. So that's a nice thing that Kotlin provides to you, so you can add on to your API and not bust it. Kotlin has name parameters. You just can refer to them by name if you want. You don't have to. We can call it combine with 1 and 2. We can call it with our named parameters first and second. We can call them backwards if we want. We can call them second and first. Just a word of warning, because parameters have names, they're now part of your API. So if you change them, you might bust somebody who's depending on that. Now, Kotlin has a really neat tool that will help guard against those kinds of things. You can integrate in your build, but just that's something to watch out for in Kotlin in any language that allows you to change, that has named parameters. Function names, this is kind of ugly. I don't like big, long test names like this. So I can put tick marks around that and put whatever I like. I do this for tests a lot. This is a pretty common idiom for tests. It's common in Kotlin if you are calling something that is a reserved word. It is not a reserved word in Java, but is in Kotlin. So the word is reserved in Kotlin, but not in Java. So if there's a function in Java, or when in Kotlin, you can put tick marks around it and call it. You can do this for functions. For tests, it's nice to be able to show in your tests a full English sentence rather than some cryptic method name. We can overload operators. Now I'm just copying it. I'm going to whip through this part. But this is just copied right out of the docs. It's not like some languages where you could, like, anything goes. You can define any operator you want with any weirdo symbols and make it look like spaceships or whatever you want to do. You can't do that in Kotlin. You have to pick from a set. I think that's a nice, reasonable middle ground. In this case, these are just simple arithmetic. By implementing plus, for example, I get plus. If it makes sense for me to add my objects together, I can implement them. And if it doesn't, I just don't. I can treat my object like some kind of set. I can see if it contains something. I can treat it like an index. I can say, give me the 10th element or whatever, like a map or an index. I can do assignment and equality. And if by implementing compare to, I can get all 4 of those symbols. So again, it's a nice pragmatic middle ground between anything goes and no operator overloading. Extension functions are another great part of Kotlin. You'll see the standard library. If you go dig around in the Kotlin standard library, you'll see it's implemented as a lot of extension functions. So to show you what an extension function is, we've been here in Java, right? We're like, well, why doesn't this object have this function on it? It should have that. Or I need to do something weird, so I'm going to come up with this static function. I'm just going to put it in this dumping ground util class, and every project has like a couple of these, right? In Kotlin, this is the same equivalent code. I'm saying int is even is type Boolean, and here's the implementation. And I can call it like this. It's a nicer experience for the developer. It looks like is even is part of the language now. It looks like it's always been built in. It's only there if it's in scope. If that function is in scope, it's there. So if I pull it in through an import, or it's in my same package or my same class, I can use it. Otherwise, I don't see it. I don't care. It doesn't physically alter int in this case. It's writing the same equivalent code or same equivalent bytecode as the static method, more or less. But it's a lot nicer development experience. And these are kind of all over the Kotlin standard library. I'm going to show you a couple that are really popular. In Java, we have this try with resources. Java 7, we've got try with resource, right? So if connection in this case is auto-closable, that'll get closed up at the end of that block. In Kotlin, we just say use. We say get connection.use and give it a lambda and do whatever we'd like. And at the end of it, that use function will close up that connection for us. We use this other one called apply. And in this case, I've got a person, I've got an expression, and two statements. And that's totally fine. But I can make this a single expression by doing this in an apply. Inside that apply, the this in the apply is the object you're calling apply on. So I can set the name and the age. This is really nice for small, lightweight builders. If you've got several of these things nested, I can do this nested structure here with an address and a name. It's pretty nice to be able to just have this as one big solid expression. So apply is pretty common. Kotlin has higher order function. Higher order function is a function that takes a function as an argument or returns one as a value. In this case, I'm ripping this off from the Kotlin standard library and removing some things that are not relevant. It's called measure time with millis, and you give it a block, and the block doesn't take any arguments, and it returns a unit. Unit is Kotlin's version of void. So it returns a unit. What we do in this, we start a timer, we call the block of code that we're interested in, we stop the timer, we return the value, right? So this is just going to measure how long it takes to call that block that we're giving it. Now, one of the things in Kotlin is that if your higher order function is the last argument in the list, or the only argument in the list in this case, I don't need the parentheses. So I can call it like this. I can just say measure time millis squigglies. And now it looks like measure time millis has always been a part of that language. It looks like it's a built-in keyword or something like that. It's a nice, again, it's a little thing, but it's more high. It provides a nicer, cleaner experience for the developer and the person reading that code later. So some final things on functions. They're all final by default. Again, if you want to allow people to extend them, you have to say they're open for extension. Arguments to functions are always final, which pleases me greatly because I'm that jerk in your code base putting final on all your function parameters. They can be defined in a file on their own. They do not have to be part of a class, to the point that the main function in Kotlin can't be part of a class. It always exists on its own. So you can put many different functions in one file. They all exist on their own at a top level if you want. And functions can be defined within other functions and can be tail recursive. If you like recursive algorithms, those things will probably appeal to you. I haven't mentioned checked exceptions. There are no checked exceptions in Kotlin, and by that I mean they are not part of the method, the function signature. Functions can obviously still throw exceptions. You can still catch them, but you don't have to. You can't declare them as part of the contract with your function, so to speak. They're all, everything turns into a runtime exception. And this is largely because checked exceptions are lies, because there are runtime exceptions. Even if I declare everything that could be checked, there are still things that are unchecked that'll slip through. So they just went with runtime for everything. We'll go with lambdas. Again, we have this list of 1, 2, 3, 4. We're creating a list. We're going to filter it down. We're going to say if it's even, we want to keep it, and then we'll take map the value and multiply it by 2. In each case, I've got one argument coming into that lambda, and I'm using that same argument on the right-hand side. Now, we can totally steal from Groovy in this case and just say, if we have one argument, I can just call it it, and I don't have to use the arrow. I can just say it. If you want to do something like this to make it more clean or call it people or whatever instead of X, you can totally do that. And some cases, labeling makes sense. But in a lot of cases, if you just have one thing, you just have to define the right-hand side of that lambda and call it, and you're good. Aliasing, that ops is sure ugly, right? I've got this fun, do something with map, and the map is this super ugly type of map of some type of list of string or something I came up with. As a developer, that's super ugly, and I don't like looking at that. So I can alias that. I can just call that operations, Kotlin will let me call that operations pretty much anywhere when I'm defining it. The code that gets generated is precisely the same, whether I have that type alias there or not. It's purely for the developer to make their lives easier. I can import alias. Have you ever written an old school DAO where you have to convert between like Java util time and Java SQL time? It's a pain in the neck because you've got to like fully qualify one of them or the other one. I can, and I don't have to do it when there's conflicts. I can do it whenever. I can alias my imports. So in this case, I can just call something else. Or I can do this. So if you check that in, that's the greatest trick in the world, is to alias things and see if your coworkers notice it. But don't tell them you got that from me. I'll close out syntax with my favorite piece of Kotlin syntax. It's called Reified Generics. So in this case, I'm creating a logger. I'm giving it a class. Don't get too wound up about like this part here, this like ugly metrics class Java thing. That's just Kotlin's way of saying, give me the Java class for the metrics type. But what I'd really like is the bottom. I'd like to be able to say, I just want a logger and use a nice type, like a generics for that. But I can't, because under the covers, the JVM is erasing those types. When it calls that function, it has no concept in this case of what T is. It just thinks it's an object, or an any in Kotlin's case. It has no idea what it is. It can't possibly give me what I'm asking for because it doesn't exist. Now in Kotlin, I can work around that. There's this concept of an inline function. An inline function will be, anytime you call it, instead of calling out to some other place in memory and executing that function, the compiler is taking the code that comprises that function and copy and pasting it into your function right at the call site. All right, so while it's doing that, since the compiler is doing it, it knows the type. So if I say that type is reified, it means remember this type because I'm going to ask you to remember it for me. So in this case, it knows that T is a metrics because it's compiling it right then. It knows it can hard code metrics in there at the call site because we're inlining. So I can do something like this. I can say logger of metrics and I just get it. It took me a while to get like why I cared about reified generics, but I kind of like this, and anytime I pull in a Java library into Kotlin and it's got one of these classes in there, I'll write a reified inline mapping function real quick just to make the code look a little bit easier. I left a lot of things out. I'm trying to get done in under time. I left a ton of things out. Kotlin is a really amazing and beautiful language. The second one on the list, massive standard library. I guarantee you, if you go through the Kotlin standard library, you'll find a lot of things that are in there that you've probably written extension functions for or are pulling in a whole dependency for just to do something interesting with strings or collections. By and large, those things have been built into the language. They're mostly already there because they have the benefit of hindsight. They have the benefit of 25 years of hindsight and be able to say, hey, this should have been there, let's put it on there. And with extension functions, the added overhead of adding to something, you're not changing the API, you're just adding another function. There's like zero stakes to adding more things to the standard library that makes developers' lives easier. In summary, I keep saying Kotlin is a fun language, and I can quantify this. Every year, Stack Overflow does a study of Java developers, of all the developers, and they say, what languages do you work with currently, and what do you want to keep working with? And for 2 years in a row, Kotlin consistently is the second least disliked language on the internet, consistently. And I've fuzzed out all these other ones here because it's like completely irrelevant that Perl is the most disliked language on the internet. The thing I want you to take away from this talk, if you don't take away anything else, if you don't like what I have to say about Kotlin, is that Kotlin makes bad choices explicit or impossible. If you're a Java developer, you should go get this book. You should read it every year. It will make you a better developer. I just flipped through my effective Java book, just was flipping through it, and these are the things that just jumped out at me that Kotlin either makes difficult or explicit or impossible. Override keyword is mandatory. Things like being able to say something is open or something is not open. These things are built into the language. I don't have to think about them anymore. The designers of Kotlin, one of whom is right over there, has to, they thought about these things and they built it into the language or forced this logic down into the compiler. And I think that's just really beautiful. If you like what I'm having to say, you can go to play.kotlinlang.org and you can go and write Kotlin right in your browser right now. You can submit something, it'll run it for you, it'll tell you what happens. You can share that code with friends and coworkers. It'll teach you, it'll give you examples. You can learn Kotlin right there. You can learn Kotlin cones, which are small problems. You can do things right there. There's a course on Coursera that JetBrains has developed. I've had 2 coworkers take it. They say it's fine. They learned a lot from it. I believe it's free. I think if you want a certificate from it, you have to pay like $50 or something. I'm not a cert guy, so I wouldn't do that. But my coworkers took it for free, and they enjoyed it. If you like what I have to say, Hadi will be in this room at 2:10 talking about functional programming in Kotlin. Come to that if you think this is what I've had to say is interesting. Ken Cousin just wrote a book called Kotlin Cookbook. He's going to be in here talking about Kotlin recipes tomorrow at this time. Tomorrow also, Ken's a busy guy. He's got functional programming in Kotlin and 2 other languages in here at 2:10. And then Mr. Roman Elizarov, who's sitting over there, will be here tomorrow talking about structured introduction to Kotlin coroutines. I'm going to butcher this, but coroutines are a great way to do, it's a great replacement for non-blocking and asynchronous code. You should go to this talk. It's going to change the way you think about synchronization and asynchrony and blocking code, doing it in an imperative way. It's like mixing reactivity and imperative. It's going to change the way you think about things, and you should go to that one. So why do I use Kotlin? I write far less code. Again, my boss isn't paying me to write code, he's paying me to deliver business value. So the code that I write is way more expressive and way more clear. I'm avoiding whole classes of defects by using Kotlin. It allows me to write in a more functional style. If I don't want to, I don't have to. Like, for example, I didn't show you a for loop, but Kotlin's got one. I just like writing in a more functional style, but again, if you don't want to, you don't have to. And it plays well with the tools I already use. I've already been a big Spring user. I've already used Gradle. I already used IntelliJ. So I kind of hit the trifecta that it's great with incidentally, but those seem to be popular tools, so it worked great with all those. And for me, writing Kotlin is just a lot more fun. And I hope you've had fun here today, so thank you very much. And it would help me out greatly if you could just, it's an anonymous thing, the questions are all optional. If you could just do that survey real quick for me, I would appreciate it greatly personally. And we got I think 8 minutes, a couple of minutes for questions if you got questions. Sir?
So I was looking at Reified Generics.
Mm-hmm.
Is this similar to Scala's implicits, or would you say it's more of just a kind of a special inline?
The question is are Reified Generics like Scala implicits? From what precious little I remember of Scala implicits, I don't think so. So this is more at compile time. The Reified Generics are getting weaved into inline things only at compile time. It's really only useful in a very specific case, like pretty much that case that I showed you.
Right, okay.
Sorry. Sir, you had a question before, the green?
So on the slide you had about the copy constructors and the data classes.
Yes.
Is that a little bit, can you achieve that, what you do with a spread operator in JavaScript? Where you do a
Is the copy operator, is the copy function in data classes like the spread operator in JavaScript?
Yes.
I think so. I'm like the worst JavaScript developer within a 20-mile radius. But I believe, from what I understand about the spread operator, I believe so.
Basically, like you copy everything except...
Yes, everything stays the same. If I had 1,000 arguments, in addition to that being a problem, and I only wanted to change one, that one that I'm specifying is the only one that would change, and all the rest would stay the same. And I get a new instance with all those things. Cool? Sir?
Yeah, the standard library is the thing that concerns me the most.
Okay.
It's sort of nice to have, but if I'm a library developer and I write a library in Kotlin and 8 other people do the same thing, don't we all begin to depend on different versions of the standard library? And how does that then assemble safely into some application later?
So the question is, how do you effectively write a library in Kotlin that doesn't compete with the standard libraries change over time?
Yeah, sort of. Right.
Okay.
My version and your library and this other guy's library, but somehow we all use different versions of Kotlin when we built them. So suddenly we depend all on different versions of the standard library. So if somebody wants to pull all our dependencies into their application, how does that?
Yeah, I mean, Scala's got that problem, right?
Yeah,
but like big time. And Java has that problem. It just moves the standard library just doesn't change that much in Java, so you don't notice it happening.
With Java, and And Java's
Right.
generally very good about
Yeah.
keeping it backwards.
I would say Kotlin is very good about not moving the standard library radically. Every recent update, so we're on 1.3 now, 1.2 and 1.3 both had additions to the standard library, but they're not changes, they're not subtractions, they're additions. So if you had an extension function in the Kotlin standard library, put it in there, you might compete with that in terms of the import order, but I mean, like I read a ton of Kotlin that other people consume, and I haven't had this problem where people are like working out over like precise versions yet. But I guess it is a risk like any other language.
We've solved it a couple ways in Scala, where basically we just stick with the statement in Scala.
Yeah.
And the entire project uses it, we don't fix.
Well, that's fine.
Yeah.
That means what I'm saying, I want to write a library and stick it in Data Central. And then 12 other people can do the same thing. We all want to write Kotlin. So somehow, and then when you pull in our dependency.
Yeah, but Java's going to have that same thing, right?
12 different versions.
Well, that's why I don't. When I write a library, I say in the docs it needs Kotlin 1. Whatever or greater, and I don't ship the Kotlin libs with my library. You bring your own. Yeah, bring your own. Yeah, I say a provided, and I make you do a bring your own. Sir.
Can you comment on compliance JavaScript and native code outside of JVM? Do you have any experience in that?
I just the examples. I've just played with it. I haven't shipped anything with those yet, but it does work. They are putting a lot of effort into that. So that's getting better. The multi-platform stuff is and the native stuff is really coming along and getting better, and they're optimizing what is being generated and the developer experience. Experimental is an overloaded word in Kotlin, but yes, I mean, it's effectively experimental, but people are using it, people are shipping to prod with it. I know a friend who has a game of life that he's written, and it's like he deploys it everywhere. It's real. I mean, it's not vapor. That's what you're asking. Sir in the yellow?
Have you heard anything about Kotlin being used within front-end frameworks like Angular, React?
Have I heard about Kotlin being used in front-end frameworks? I think there's like a Kotlin React, the Kotlin JavaScript and React bindings. I've got a coworker who's playing with that. They say that it's working out pretty well. But again, I'm not a front-end person, so I'm probably like the worst person to answer that question for you. I'm sorry. Sir?
I got a couple questions. The first one is, you know, with functions and whatnot, types don't have to be explicitly stated.
Correct.
Does this slow down the compiler?
Does type inference slow down the compiler? If it does, I haven't noticed.
Okay.
Not markedly so. Let me say it that way.
Because it was a problem that we had in Scala.
Yeah.
With some of the earlier versions.
Then Dottie should fix a lot of that, right?
Yeah,
So
it is, and Scala 3 is coming out too.
yeah.
And then my next question is, like, what's kind of the library maturity in Kotlin now? Are you finding that now people are writing APIs for Kotlin? So like, you know, Spark releasing Kotlin API. And
So the question is, what's the API stability in Kotlin? Do I see people writing those? Yeah, like there's a lot, especially in like the testing frameworks. There's a lot of like Kotlin specific testing frameworks that are like, there's one called Mock with 2 Ks. That's wraps Mockito that is really, really nice for Kotlin because it gets rid of a lot of like the weird Kotlinisms that are hard with Java. So you do see people writing libraries.
And are we getting concurrency primitives like libraries coming out?
Are we getting concurrency primitives? You should go to the Roman Elizarov's talk about that. I don't do it justice, but he's a brilliant guy, and it's the coroutines in Kotlin are brilliant. All right, I've got to wrap it up, but why don't you come on up and ask?
For the extension functions, do you have to import them?
Do you have to import extension functions? Kind of, but not really. If they're in scope, if they're in the same package, you don't. But if they're in some other package in some library, you might have to import them. But IntelliJ is really good at finding it and figuring out what you want and doing it for you. Thanks, y'all.